Welcome back, everybody. I should be collecting all your guys' exam redos up here. If you have it, please just bring it to the front real quick. But we left off last time with domains and finding them algebraically. So, as a reminder about what domain is, it's all the x values that get attained by points on the graph. But when you're talking about the function, the actual equation of the function, and you're not given the graph, we need to be able to interpret what that would mean. And so what that would mean is you would be able to find the value, you'd be able to plug in that x value specifically, is what I mean to say. So with the first example, the domain is all real numbers because no matter what x value you choose, it always ends up giving you an actual value. You plug in 5, you get a corresponding y value. You plug in 10, you get a corresponding y value. So every point, every x value is part of the domain because you can always plug in the x values. Whereas with part B, if we were to plug in -2 or 8, we would end up dividing by 0, which is not possible. We cannot divide by 0. So that's what we're doing. We're trying to figure out where the function is undefined. And that would be trying to find out where we're dividing by 0 or where we're taking square roots of negative numbers or some combination of the two. Later on, we'll talk about logarithms, and that'll be an added extra step. And we'll also talk about piecewise functions and domain. But for now, though, like by and large, those are the two main things we're worried about, is not making sure we're not dividing by 0 and we're not taking even roots of negative numbers. So we found out that therefore the domain would be -infinity to -2, union -2 to 8, union 8 to positive infinity, all with parentheses. Now, why is that? Ideally, you can kind of see it, but if not, here's a little picture that you can always draw to help you out. If you draw a number line, here's -2 and here's positive 8. From the purple, we know that these two numbers need to be plucked out. Those two numbers are not part of my x values. They cannot be, as we just saw with that little equations that work on the left. But everything else is part of the domain. So that's uh, -infinity to -2, -2 to 8, and 8 to positive infinity. So you can always draw a number line to help you visualize it. As you get better and better at this stuff, you don't need to see it in front of you to figure out what the domain would be. But I guarantee you, if you try and plug in 0 into this equation, you'll get positive 1/4. It'll exist. You can plug in 10. I don't know what the value would be, but you can plug in x equals 10 and you will get a corresponding y value. The function exists there. Any questions on that? On the next one, h of x is equal to 15x over x squared plus 9. So once again, the numerator doesn't matter. The numerator equaling 0 doesn't do anything. 0 in the numerator isn't a problem. 0 divided by 5 is 0. 0 divided by 10 is 0. It doesn't matter. The only thing that we have to worry about are denominators. So, much like before, we'll say, okay, well, we need x squared plus 9 to not equal 0. However, what I'm going to tell you immediately is that the domain is all real numbers. You might be thinking, Phil, what about 3 and -3? This isn't a difference of squares. This is a sum of squares. And what we learned in 0.6 is that sums of squares are prime. They don't factor. The solutions to this, to x squared plus 9 equals 0, are 3i and -3i. They're complex numbers. So the thing is, x squared plus 9 is never 0. In fact, x squared plus 9 is strictly greater than 0. So we have no x issues. X squared plus 9 is always strictly greater than 0 because 9 is a positive number x squared is a positive, is a number greater than or equal to 0. So together they are something that is strictly positive. No matter what you plug in for x, this number will be larger than 0. So it could never equal 0. And as such, the only thing that could cause problems was the denominator, and it's never equal to 0. So this function's domain is all real numbers. Any questions on that? Okay. Oh, let me keep that up there for people writing. I do want to mention, I want you to look at questions B and A and notice the very, very close similarity. It's the exact same square root function. It's just the first one is just the square root, whereas the second one is 1 over that square root. So let's first talk about part A, and then we'll talk about part B. It's dealing with a square root, an even root. And even roots need to have their insides positive, otherwise they start producing complex numbers. So in particular, with this one, we need 3x minus 11 to be greater than or equal to 0. Remember, the radical, the square root is defined at 0. The square root of 0 is 0. We write that like you're not needing to write this down just so we can see it in our head. The square root of 0 does exist. It's 0. But anything less than 0 is a negative number, and square roots can't handle negative numbers, at least not in the real world. So that is a linear inequality. We can solve that. We add 11 to both sides. We get 3x is greater than or equal to 11. That gives us x is greater than or equal to 11/3. So the domain, or actually, let me write it down here. The domain is therefore bracket 11/3 to positive infinity. But just like usual, just like before, if you're having a hard time seeing the answer immediately from this work, draw a number line. It'll work wonders. So if I were to draw a number line, here is 11/3. And we know that our x values need to be larger than, so to the right of 11/3. So it's everything to the right. Hence, bracket 11/3 to positive infinity. Any questions on that? Now this one, the next one, k of x is equal to 1 over the square root of 3x minus 11. So I'm going to tell you that we need 3x minus 11 strictly greater than 0. But the square root's defined as 0. Why are you only writing it strictly greater than? Try and think about that. Why would it be that I'm saying it needs to be strictly greater than? Because the denominator can't be 0. Yes, the square root of 0 does exist. It's 0. But if it's in the denominator, that would mean that you're dividing by 0, and that's a big no-no. So there's no or equal to, because if 3x minus 11 equals 0, we get 1 over the square root of 0, which is 1 over 0, which is undefined. So it's a combination of the two things. It's in the denominator, so it can't equal 0, and it's inside the radical, so it has to be greater than or equal to 0. But we just said it can't be equal to 0, so that's why it's only a strictly greater than and not a greater than or equal to. But the equation gets solved the exact same way. We get x is greater than 11/3. So the domain is parenthesis 11/3 to positive infinity instead. Any questions on the difference between A and B? All right. Next one, the last one. This one's a fun one, in my opinion. It's got two things involved. It's got a square root in the numerator and it's got a denominator involved. So I'm going to color code it and say that there are two conditions. Up top, we need x plus 3 greater than or equal to 0. So x needs to be greater than or equal to -3. X needs to be greater than or equal to -3. Because otherwise, this we'd be taking the square roots of negative numbers. If we try and plug in -4, you get the square root of -1, which is not a real number. Then from the denominator, which I'll do in blue, we know that x minus 2 cannot equal 0, meaning that x cannot equal 2. So both of these need to be true at the same time. So yes, I can plug in -4 into the denominator, right? -4 minus 2, that's -6. That's okay. But we'd be taking the square root of a negative number up top. We'd have -i. We'd have I over, we'd have the square root of -1 divided by -6. It's not a real number. And the flip side, even though 2 exists in the square root, we'd be taking the square root of 5 and dividing it by 0. So that's a problem. So on a number line, we have to take care of both of these conditions. Here's -3 and here's +2. From the red, we know that everything to the right of -3 is fair game. However, the blue says that 2 cannot work. So we have to pluck this out. We have to still remove it. I feel pretty proud of my color choice here, by the way. This red plus blue is equal to purple. Isn't that cute? My son's son's learning about color theory a little bit. So, I mean, color theory. He's not not studying theory at the moment, but anyways. So looking at this and writing on a number line, therefore, not on a number line, in interval notation would therefore be that the domain is bracket -3 to 2 parenthesis union 2 parenthesis 2 to positive infinity. Any questions on that? So it has two conditions. We can do this in a bunch of different problems too, but there's many more that we can do. And it always ends up being that all the conditions need to be satisfied. If one of them is not satisfied, the whole thing's undefined. Any questions on that? Okay. One last thing is this bonus example. Notice that h of x is equal to the square root of x plus 3 over x plus 10. Notice that's basically the same as lowercase h. That's why it's called capital H. The only thing that's different is instead of an x minus 2, it's an x plus 10. So with this one, as you can see, I'd like you to try and figure it out in your own time, but you'll see that the -10 actually doesn't even matter. So give that a ponder and ask a question later on if you have questions about it. I'm happy to go over it in detail later on, but I want you to think about that problem for a little bit. Okay? Any questions on that? No? Okay. One last thing in this section. This is something that I think is very, very important, and we haven't really seen it from this perspective yet. So I want to think about solving equations, but from a functional standpoint. This might seem a little bit contrived at first, and it might seem like unnecessary. However, you will do this in Math 182 and a little bit in 181 if you decide to take those classes, Calculus 1 and Calculus 2. So it's important to think about this. If we're considering the equations x squared minus 6x plus 1 equals x minus 5, the first thing that the first observation that I've mentioned here is that we know how to solve this. Bring everything to one side so that one side's 0. That way we can factor it and have a product equaling 0. And thereby we can use the 0 product rule to get that the solutions are 1 and 6. And then what we've learned is that we can check our work by plugging in that suggested upon value and seeing whether or not we get a true statement. So if you plug in 1, you'll get -4 equals -4, true statement. Plug in 6, you'll get 1 equals 1, also a true statement. The next observation, so that's stuff that we already knew. That's stuff we already knew. Now, because each expression by itself, you could make it into a function. So I can make the left-hand side f of x is equal to x squared minus 6x plus 1. And the right-hand side, g of x, I can write that as x plus minus 5. So f of 1 is equal to -4, and g of 1 is equal to -4, because if I plug in 1 into this equation, like you see in observation 1, we get -4. And similarly for 6, if I plug in 6 into this into f of x, 6 squared minus 6 times 6 plus 1 is equal to 1. And 6 minus 5 is equal to 1. So we know that the points, by my theorem, remember that important fact, if f of a is equal to b, then a comma b is on the graph. So this theorem says f of a equals b if and only if a comma b is on the graph. So this means that the points 1 comma -4 and 6 comma 1 are on the graphs of both f and g. In fact, if you look at the graphs which I've provided here, they're the only 2 points where those curves have the same values. They're the only 2 points that those 2 functions share. These are the intersection points of f and g. So now we can think about equations in a different way. We can think about them graphically. Solving equations is equivalent to finding where the 2 curves intersect. So that's a pretty cool, cool is relative, right? It's a unique way to think about these things, to understand that setting 2 equations equal to each other is the same thing as finding where those 2 curves intersect each other. So a fun little add-on to understanding like a new interpretation of equations. While not useful too much right now, it is one way to check your work on equations, right? You can graph the 2 equations and see what x values they have in common. But in addition, it will help you a lot in your future math courses. In Math 182, you talk about areas and volumes between 2 curves. And in order to find those out, you need to know where the 2 curves intersect, which is precisely where you set the functions equal to each other. Okay. Now on, unless there's any questions on that. On to lines. So back over here. So you might be wondering, why did I combine it as 1.4/5? So when I originally wrote the notes, when I was originally working through it, I was like, well, this is stupid. Like, we can put all of this in one section. Even though it was 2 sections, I was like, I could just combine them. And so I wrote them as 1.4/5. Why not just change it to 1.4 then, Phil? Well, I continued writing, and so now if I had to change it, then everything would have to be changed, including all my old worksheets. So 1.6 would now have to be converted to 1.5. So all the examples that say example 1.6.1, example 1.6.2 would now have to be 1.5.1, 1.5.2. And I had to do that for 4 other sections, and I'm not doing that. I'm not doing it. So deal with it. Anyways, so we already saw the slope formula for the line. Y sub 2 minus Y sub 1 is over X sub 2 minus X sub 1, or the rise over the run. And then one of the important things, if you're going to be using rise over run, is that going up means a positive rise, going down means a negative rise. Going right towards the positive values is a positive run, and going left towards the negative values is a negative run. So we already calculated the slope one time. Let's do it again now. So we have a line with the point 5 comma negative 2 and a y-intercept of negative 2. I don't have 2 points, but yes, I do. Remember, a y-intercept is actually a point. A y-intercept of 2, that just means the point 0 comma negative 2. So this is my x sub 1, y sub 1, and this is my x sub 2, y sub 2, though it doesn't matter which one you choose for which, just as long as you're consistent. So if you're trying to memorize a formula, rewrite it. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that will be, so negative 2 minus negative 2 over 0 minus 5. That's 0 over negative 5, which is just 0. And it makes sense if you were to actually graph this equation. So I'm going to do it on this bottom right graph section just for a second, so you can see. So negative 5 comma negative 2, or 5 comma negative 2 is right there, and a y-intercept of negative 2, that is a horizontal line. And horizontal lines have a slope of 0. So it makes sense that the answer is 0. I only say that because I know for me in mathematics, and it's something you'll find out in the more math you take, if you start getting like a lot of problems, they end up actually having an answer of 1 or 0. And you're like, that's too nice of a number to work out. That's too nice. How could it be 0? So you can graph it to verify it to yourself. The answer should be 0 here. Okay. Next one. Part C. You're given the graph. Now you can go ahead and find the 2 point, like I've like it's not very well labeled unless you zoom in a lot. In which case this is when I was trying to add arrows inside like Desmos, the program I used to draw graphs. It doesn't allow me to add arrows at the ends of curves. So I had to like make a makeshift an arrow in PowerPoint, but it's impossible to find I mean, it's not impossible, but it's very difficult to get this thing to line up perfectly on top of it. So, but anyways, I'm getting sidetracked. It's hard to see them, but I have these 2 points. So if you want to, you can use the slope formula. You can make this your x sub 1, y sub 1, and this your x sub 2, y sub 2. So 2 comma negative 3 and 7 comma 0. You can do that and it's fine, or you can use rise over run since we have the graph at our disposal. Now, I want to show you both ways. So you can either start with this point and then work your way over to this point, or you can work backwards. It doesn't matter which one you do. If you decide to, like, the convention is to go from left to right. It's how we read. And if that's the case, we'd go up 1, 2, 3. So a rise of 3, and then 1, 2, 3, 4, 5. A run of 5. So the slope is m equals a positive rise of 3 over a positive run of 5. Now, just because we did it that way, sometimes it's hard to have a point. Sometimes you don't have a point to the right, and you have to work left, or you have to go to the left. So just in case you don't need to draw this, but I want to show you if you want to go the backwards direction. So you start with the point at 7 comma 0. 1, 2, 3, 4, 5. We went left 5, so that's a run of negative 5. And we went down 3. a rise of -3. But it still ends up being the same number. A -3 divided by a -5, the negatives cancel, leading to a final result of 3/5. So it doesn't matter which one you do, just as long as you remember going right means a positive run, left means a negative run, up means a positive rise, down means a negative rise. All right. Any questions on those? And then this last one. What's the slope of that line? Not zero. Zero would be a flat line, a horizontal line. But you are right in saying that it does involve zero. It's a zero in the denominator. It has zero run. And you cannot divide by zero. This is an undefined slope. So a vertical line implies an undefined slope. This is the line x equals 2.5-ish. X equals 2.5-ish. And you can prove it to yourself, like you can use the slope formula. You can pick any 2 points on them, this one, and take the difference, or like the difference in the x, y's divided by the differences in the x's, and you'll see that you get over zero, and it's problematic. So, as a fun little challenge problem that I highly encourage you to do, try this one. So there's 5 lines listed here, L1 through L5, and you want to arrange them in terms of their slopes from most negative to most positive. And it's a pretty fun problem. Just remembering that the steeper the graph, the more positive or more negative the graph, the slope would be. So just to give you a hint on the starting point, the slope of L5 is smaller than the slope of L1 because L1 is a steeper positive slope. Because L1 is a steeper slope, like a steeper line, it has a larger slope. So, anyways, fun problem to do. Definitely a good one to do over this weekend. Bring this to your next family gathering and just bust this out instead of playing Uno or whatever. Uno can cause real rifts in a family. So don't play Uno. Just have this problem out instead. All right. Then we went over in the video, we went over the 3 main forms of lines. General form, which we won't encounter too often, but it is important to work with, especially once we get to Unit 4, when we talk about systems of equations, which naturally extends to matrix algebra, which we won't go over in this class, but matrices are really cool. Then there is slope-intercept form, which is the best format if you need to use the line for something. If we want to find whether a line is perpendicular or parallel to our line, or if we want to find out the x or y intercept of our line, then that's the good format. But the far superior form, my favorite form, is point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. Because it allows us to compute or create lines very, very, very quickly. And then the key thing is that you can go from point slope form to slope intercept form by just doing a little bit of simplification. So we did one example right here. And then I want to do another one. So find the equation of a line that passes through the points -1, -4, and 2, 2, and then graph the line. So there are many ways we could go about this. We could either plot the line and then use the rise over the run. That would be fine. However, I'm going to do it differently. I'm going to use the slope formula and then use point slope form for the line. So this is my x sub 1, y sub 1. And this is my x sub 2, y sub 2. So first we need the slope, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that would be 2 minus -4, so that's really 2 plus 4 over 2 minus -1, so that's really 2 plus 1. So that's going to be 6 divided by 3, that's 2. seriously, please take me at my word here. Like, please believe me when I tell you, if you need to memorize formulas, rewrite them every time you do a new problem. You will thank yourself, your future self will thank you. If you need to memorize the formula for whatever reason, if it's my class, chemistry, physics, whatever it may be, if you need to memorize something, rewrite it each time. It's just free practice. So, slope is 2. And then the point slope formula is y minus y sub 1 is equal to m times x minus x sub 1. Do you need to use x sub 1, y sub 1? No. You could use x sub 2, y sub 2 if you wanted. It'll be the same line. It'll look different, at least at first, but I guarantee you. So I'm jumping the gun. So this would be y minus -4, so y plus 4 equals m, which is 2, times x minus -1, so that's really plus 1. Or if you want to write it in slope-intercept form, if you must, for whatever reason, distribute the 2, subtract the 4 from both sides, and you should get y equals 2x plus 2 minus 4, which is y equals 2x minus 2. I'm going to put this in that format because I don't like it as much. I don't think it's as good of a line formula. Bill, why do you have such hate for point slope-intercept form? It's more just an admiration for point slope form. It's what I like. I teach a lot of like my favorite course to teach is this one and calculus. I love calculus a lot. I love pre-calc 1 a lot. And because I like calculus so much, this format is far superior in calculus. It tells me a lot more about a curve than anything else. So that's why I like its format more. So any questions on that?
Yeah. How do we convert to slope
intercept
form for b? How do we get b again?
How do we get the b value of -2?
Yes.
So first I would distribute the 2 in. That's where I get the 2x plus 2. And then I'm subtracting 4 from both sides. That's where this -4 is. And then when I combine like terms, or like the like terms of the plus 2 and the -4, that's right. Back to my point, what I was saying, thank you for asking that question. You could use x sub 2, y sub 2. So another version of this line that exists is y minus 2 is equal, and you don't need to write this down, 2 times x minus 2, like this. That is the exact same equation as the other one. All 3 of these equations give me the same thing. I guarantee you, if you FOIL this out and distribute and have a grand old time, you will get the exact same slope-intercept form. So it is okay to use either point. And then it asks us to graph them, so we can just plot the 2 points. -1 comma -4 is right there. And 2 comma 2 is right there. Now that we've got 2 points, we can connect them with a line. If you've done this on ALEKS, if you haven't done this on ALEKS yet, it gives you like this little tool, and it forces you to plot a point. And so you'll plot this point, and then if you want to, like, if you're given another point, like on this problem, you can just move it over to that point and plot it. But sometimes, like on the previous example, it gave us the slope instead. So what you can do is plot the point, and then with the cursor go up 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and you'll plot that point. That's how it works. All right. Last problem. In this section before we go on to perpendicular and parallel, right? Nope. We still got a little bit more. Given the line 4x minus 7y is equal to 21, identify the slope and the y-intercept, and then graph that line. Okay, the line is given to us in general form. It tells us to identify the slope and the y-intercept. So converting our line to slope-intercept form, slope-int form, would be perfect. Because we need to find the slope and the y-intercept, this is a perfect candidate to convert it to slope-intercept form. So we've got 4x minus 7y is equal to 21. We need to solve for y. That's how we get it to be in y equals mx plus b form. So we'll subtract 4x, get negative 7y is equal to negative 4x plus 21. At which point we will then divide both sides by negative 7. Now, John Doe student does a silly mistake. He does this. You cannot divide just one term of the right-hand side. When you divide an equation by a number, you divide the entire equation by that number. Both sides, the entirety of both sides. So it's not like that. You have to do the whole thing. Well, that will give me y equals negative 4x divided by negative 7 plus 21 divided by negative 7, which is y equals 4/7 x minus 3. So we need to find the slope and the y-intercept. M is our slope, B is our y-intercept. So M is equal to 4/7 and B is equal to negative 3 or 0, negative 3, depending on the circumstance. Right? Some people like to have their intercepts just listed as the y value. So in this case, negative 3. Otherwise, they might want it listed as a point. So 0, negative 3. And then we'll graph it. So the great thing that that slope-intercept form gives us is it gives us a point. In this case, the y-intercept of negative 3, which we'll plot right there. And then all we need to use is the slope to find another point. So we'll go up 4, 1, 2, 3, 4, and then go over 7, 2, 3, 4, 5, 6, 7. To plot the next point. And then we connect those two things with a line and we're golden. And on an exam situation, if I do have any problems where you have to graph a line, it doesn't need to be a perfectly straight line. Yes, on an iPad, I'm able to do that, but that's not required. Any questions on that? Yes.
From this form, the slope intercept form, how can we convert that to?
Point slope form?
Yes.
Excellent question. I was hoping someone would ask that. So Victor's asked, how do we convert a function, a line from slope intercept form, like y equals 4/7 x minus 3, to point slope form? And the answer is you don't. You don't want to. There is a way to do it, but it is very, very convoluted and it's never really needed. The thing is, so remember my rule of simplification is that if you need to use the line for if you need to use what you found for something, simplify it. Otherwise, leave it as is. Point slope form is really great if that's all you're asking for. But if you're asking to find something out about the line, then you want to convert it. There's never a reason to go backwards. There's never a reason to go from slope intercept to point slope. So, excellent question. All right, 3 more questions, and then we get to perpendicular and parallel and applications too. So, given that a line passes through the point 4, negative 7, find its equation if its slope is 0 or if its slope is undefined. All right. So the answers are going to be y equals -7 and x equals 4. Those are going to be the answers. But why? Why is that the case? And why did I know it so quickly? First and foremost, we have to, maybe it would help us to draw the lines themselves. So I'm going to underline this one in red and this one in blue. So let's plot the point 4 comma -7. 4 comma -7 is right there. And let's draw a line with slope 0. That would be a line like this. And that's a y value of -7 there. So if you remember from the first page, don't worry, I'm coming right back to this. If you don't have it finished, don't worry too much. But I'd rather you look at this. Horizontal lines have a slope of 0, and they are always in the form y equals b, where b is the value that they cross through on the y-axis. And undefined slopes are always vertical lines, and they always equal x equals a, where a is the value it crosses on the x-axis. So with a point 4 comma -7, if I draw a horizontal line, it has to go through -7 because that was the y value of that point right there. Every point on this line has a y value of -7, right? 5 comma -7, 10 comma -7, -8 comma -7, so on and so forth. And on the flip side, if I draw a vertical line through this point, you'll see that it goes through, it intersects the x-axis at 4, hence the line x equals 4. Any questions on that? Okay. Now, I made this problem. I need to edit it. Did I make this comment to myself before? Sorry, 1 second. I'm going to make a comment to myself. Did I make anything on 1 point? Okay. Make example 1.4/5.6 have a not nice y-intercept. Okay. It's just a line for me to make some edits on this thing. Because there's an easy way to answer this problem, and there's a more generalized way. It takes a little longer, but it encompasses more options. Because with this problem, the very, very quick way to do it is to say, oh, well, the y-intercept's 2, done deal. Then all I need to do is find the slope, and I can just do that by going 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 6/5 x plus 2. We're done. But what if the line didn't look like that? What if the line looked something like this? What if it looked something like that, where we don't know what the y-intercept is offhand? It's very, very difficult. It looks like it might be 3.5, but we don't deal with guessing in this class. This is math. We don't guess. We verify. So let's use the more generalized approach, because it's better, because on an exam or on the homework, it might not be like this. If it is, take advantage, absolutely. But instead, we have the point of 5 comma 8, and we have the point -5 comma -4. It doesn't matter which one I choose to be my x1 y sub 1 or my x sub 2 y sub 2, but convention would be left to right. So x sub 1 y sub 1 is the bottom left point. X sub 2 y sub 2 is the top right point. So we will go with this. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Do we need to use the slope formula? No, we could also do it by doing rise over run. We could go up 1, 2, 3, 4, 5, 6, 7, whatever this is, over this amount and figure that out. That is fine too. The only problem with that is on a computer, it's kind of hard unless you're okay like putting your pencil on your screen. I worry about getting ink on it and things like that, so I don't do that. But it's not my technology. You can do whatever you want. But you could do that instead, or use your mouse. But that's always shaky for me. Either way, however you want to do it, you'll get 8 minus -4, so 8 plus 4 divided by 5 minus -5, so 5 plus 5. That's 12 over 10, which reduces down to 6/5. From here, all we need to do is utilize the point slope form. So y minus y sub 1 is equal to m times x minus x sub 1. And therefore, y plus 4 is equal to 6/5 times x minus -5, so x plus 5. That is an acceptable answer unless they want it in point slope or slope intercept form, in which case we just need to distribute like normal. Or we get y is equal to 6/5 x plus 6 minus 4. Y equals 6/5 x plus 2. It will. Any questions on those? So the 6/5 x plus 6 minus 4 is coming from distributing the 6/5 in. When I distribute it into the constant, the 5's cancel. That's why I got a plus 6. I'll subtract 4 from both sides. That's why I've got that -4, which reduces down to plus 2, which just so happens to be its y-intercept. So, any questions on that? All right. Well, and this is a good time to take a break. Let's come back at 12:58. Let's come back in 10 minutes. We got 1, 2, 3, 4. Yeah. Let's come back at 12:58. People are according to do some guided meditation. Back to it, and we'll talk about the next portion, which is kind of like the previous portion was less 126 material. This is the more important stuff. So let capital L1 and L2 be lines with slopes m sub 1 and m sub 2 respectively. The two lines are said to be parallel if they have the same slope. We denote it by two slashed lines. Two lines that look like they're parallel. And mathematically, so that's what we would say in words to tell us what parallel lines are. But mathematically, it means that m1 is equal to m2. M sub 1 is equal to m sub 2. And one of the key facts about parallel lines is that they never intersect, at least in the Euclidean geometry. In Euclidean geometry, parallel lines will never intersect. However, if you start talking about elliptic geometry or spherical geometry, parallel lines do intersect, which is pretty weird. But that's a completely different geometric system, not something we work with in daily life. Then, two lines are called perpendicular if they have what we call opposite reciprocal slopes. Opposite reciprocal. And we denote it by an upside down T because it looks like two lines that are perpendicular. They intersect each other at a 90-degree angle. Now the question, so you might hear other people, like if you look at videos online, you might hear people call it something different besides perpendicular. You might hear them say a name called orthogonal. And orthogonal is the more correct term for more dimensions. Once you add a third dimension, there are many different ways to be perpendicular to another line because it's not just up and down, it could be in and out like that. And so then you have like what it means to be like perpendicular means a specific thing. So, anyways, opposite reciprocal. What the heck does that mean? It means a flipped version. A reciprocal is the flipped version of a fraction. I think we already talked about that. So an opposite reciprocal would be the opposite sign. So for example, if we have 4/3, the opposite reciprocal of that would be -3/4. And if we had -2, the opposite reciprocal would be +1/2 because -2 is the same thing as -2 divided by 1. So if we flip it and multiply it, we get 1/2. Mathematically, so this is something that not many people get to like see it this way. I'll write it down, but you don't need to know this. Most textbooks will write it just this way. M sub 1 is equal to -1 over M sub 2, or M sub 1 times M sub 2 is equal to -1. The secondary way that I've written it, M sub 1 times M sub 2 is equal to -1. That is the mathy way to write it. That is the way that I look at it in mathematics. If I'm trying to figure something out in 3 dimensions or beyond, this is something that I'll do. I'll use that terminology, but this is something that only really mathematicians do. All right. Most important thing you need to know is that it's the opposite reciprocal. It's like that. Doing that is the most important thing. So write the equation of a line that is parallel to f of x is equal to -7x plus 3 and passes through the point 5, 6. So f of x is equal to -7x plus 3. That is a line just written in function notation. And we want a line that's parallel. So our given line is y equals -7x plus 3. So its slope is equal to -7. We're trying to create the equation of a line that's parallel to it, so our slope will be the same. That means that m sub parallel is equal to -7. So we have a slope, we have a point. We'll call this the point x sub 1, y sub 1. So we know exactly everything that we need. Y minus y sub 1 is equal to m times x minus x sub 1. So that's going to be y minus 6 is equal to -7 times x minus 5. Or if we really want to, y is equal to -7x plus 35 plus 6. So y equals -7x plus 41. Either way. This is something I meant to say earlier, but I just want to make sure it's clear. On exams, I will never ask you to write the equation of a line in one format or another. It will always just say write the equation of a line in any form. So if you prefer to write things in slope-intercept form, be my guest. That's fine. Otherwise, leave it until later. Leave it in point slope form. All right. So this one was given a parallel slope. So we needed to find like the slope was the exact same. The next one, find the equation of a line that is perpendicular to 2x plus 7y equals 12, and it passes through the point -4, 4. Okay. So we've never done one of these problems before, but that's not a reason to shy away from it. We just instead have to really just think about what we're trying to do. We're trying to find the equation of a line. To find the equation of a line, I need to either have 2 points or a point and a slope. I don't have 2 points, and there's not really, I only have one, and there's not really a way to find out another point on the new line that I'm trying to find. So it must be that I need to find the point. I have a point, I must need to have a slope. So what should I do? Is there a way to find the slope of the given line? Yeah, we can write in slope intercept form. So let's first do that. So we're going to put this in slope intercept form to find its slope. So 7y equals negative 2x plus 12. We'll divide both sides by 7 to get y is equal to negative 2/7 x plus 12/7. Any questions on any of the algebra there? Okay, if there is. From this point, now we have a slope of a given line, but we want a line that's perpendicular to it, so we need to find the opposite reciprocal. So this slope is m is equal to negative 2/7, but that means that m sub perpendicular, so m upside down t. So m sub upside down t, that means m sub perpendicular. That's what that means. That's the perpendicular slope is equal to positive 7/2. Opposite reciprocal. So the first slope was negative. Our resulting slope will be positive, and we flip the fraction. That's why we got 7/2. So we have the slope. We have a point. We have everything we need. Y minus y sub 1 equals m times x minus x sub 1. Phil, do I really have to keep writing it? Yes. Until you've got to memorize. You might be thinking seems silly, this seems pointless. You'll be using lines in every math class from here on out. I mean, 127, you probably won't use a line, so you'll probably forget this formula, but you'll be quickly reminded of it in calculus. And then in Calc 2, you'll still have to do it again. And then in Calc 3, you'll start doing tangent, instead of tangent lines, you'll be doing tangent planes, which is just the three-dimensional analog of a line. So it's important. It's never going away. Y minus 4 is equal to 7/2 times x minus negative 4, so plus 4. That is an acceptable answer, though sometimes they want us to write it in slope intercept form, which we can do. Y is equal to 7/2 x plus 14 plus 4. That's coming from when I distribute the 7/2 into the 4. It becomes 7 times 2, which is why I got the 14. And then I add the 4 to both sides from this minus 4 here. That's where I'm going to get the other option, which is y equals 7/2 x plus 18. Either format is fine. But I have a preference. Any questions on that? Time is up. Yeah, it's good. Try. Yes.
So with these forms,
Mhm.
if we plug in a y and x value, will that just give us another point on that line?
Mhm.
Okay.
Yeah, so if we pick another x value, we'll get a corresponding y value, and that will just be another point on that line. Good. Next one. I'd like you guys to work through this one. Find the equation of a line that has an x-intercept of 4, 0 and is parallel to the line below. Go ahead and try and work on it. I'll slowly fill in details. And people watching the recording, you should pause it and figure it out yourself. So this is the answer you should get. You should get y equals 9/5 x minus 36/5, or the point slope form, regardless of what you choose. So we want a line that is parallel to the line pictured below. In order to find the equation of a line, you need either 2 points or a point in the slope. We're only given 1 point on our desired line, 4, 0. So there must be a way to find the slope of our desired line. And the fact that it is parallel to the given line is the giveaway. So we need to find that slope, and you can either use the slope formula, or you can use the graph itself to figure it out. I used the graph this time. On my notes, I decided to do it with the points. But so that's a rise of 9 and a run of 5. So that's 9 over 5. So we have our slope of the given line is 9/5. And that means that the slope of our parallel line is the exact same, because parallel lines have the same slope. That's where we get 9/5. And the point given is 4, 0. So then we can use point slope form to find out the equation of our line. Any questions? Okay. So there's a fun challenge problem at the bottom. Don't worry, I'll come back up here, but there's a fun challenge problem. I encourage you to do it in the space provided above. It's a fun problem this weekend. Crack open a few cold ones with the boys, right, and bust this out. I know we want to play Fortnite, but let's spend a fortnight doing this problem instead. I know you guys, do people still play Fortnite? I've never actually played. Never been my cup of tea. More of a MOBA person, you know, good old Dota. Because I hate myself. That's the main reason. Because I like people saying mean things to me. That's the reason why I like playing MOBAs. Okay. Yes. That is correct. Yes. On Alex, it usually allows you to write the equation in both formats, but sometimes it has y equals and then there's the enter box, in which case you're kind of forced to do it in slope intercept. But if it gives you a box and you can write whatever you want, you can write it in point slope form. It'll accept it. All right. So on to the applications. Everyone's favorite part. I know we're all so excited. It's word problems. Everyone loves word problems. I like it frequently every semester. It's people like, I'm so glad we get this section. Is that what you guys are thinking right now? No. One year, people will actually like application. 1 year it'll happen. But until then, we'll just keep chugging along. So the key thing is that since slopes represent a rate, we can solve real life situations that involve related quantities. So the slope is a rate. So whenever you see a rate of something, so that's going to be things that say something per something, right? Feet per second, that's a rate. Dollars per hour, that's a rate. Gallons per minute, that's a rate. So that is a good indication for these types of word problems. If you see a rate, nine times, probably even 999 times out of 1,000, that is going to be the slope for that problem. So slope and rate are synonymous. So let's look at this example. And then here's another thing, by the way, is you need to define your variables. Not for me, but for you. It's much more, a problem is much more approachable if you label your variables. Because if you're able to label your variables, you know what you're looking for. And by putting it onto paper, that allows you a lot of ideas on how to get started. So that is honestly the hardest part that I've experienced with word problems. I don't have too much of a problem with word problems myself, and that's because I'm a math major. But I do have a lot of problems getting essays started. I'm not an English person. I never have been. But what I realized, and it was kind of a nice analogous thing with mathematics, is getting started is the hardest part. Like, it can be absolute gobbledygook at the start, but it's enough to get you started. Just like with an essay, of course, your first rendition of your essay isn't going to be good. It's going to be crap, and you're going to have to edit it. But once you've got something to work with, then you can actually start shaping it properly. Same thing goes with this. So the monthly cost in dollars of a phone plan is a linear function of the total calling time in minutes. The plan starts at $34 and you're charged 11 cents per minute of usage. How much will the bill be if you were on the phone for 4 hours and 22 minutes this month? So this is a ridiculous question, isn't it? Because we don't really have data plans like this anymore. Oh, these are the golden times, right? It's the good old days where you had to be text. You also were charged for the text messaging. Ah, good times. So, okay, we're trying to find out how much our bill will be. So we can use whatever variables we want. Let y equal the amount of money for your bill, and let x equal the number of minutes. It doesn't need to be super particular. You don't need to write a paragraph here to define your variables. I literally just said let y equal money sign and x equal number of minutes. It's just meant to be something so that if someone was reading your work, they'd know what x and y represented. So let's look through this and say it says that the plan starts at $34. So this means that when x is 0, y is equal to 34. So we have a point 0, 34. We have an x value, we have a y value, we have a point 0, 34. And we're charged 11 cents per minute of usage. That's $11. That's a y value divided by an x value, number of minutes. It's a rate. So you are charged 11 cents per minute of usage. That tells us that m is equal to 0.11. And in particular, that's a y-intercept. So we actually have the formula already done for us. We have y is equal to mx plus b. So it's going to be y equals 0.11x plus 34. All right. So we found the equation of that models the cost of our plan in number of minutes. So if we are only on the phone for 1 minute, we'll be charged $34.11, and so on and so forth. So the question asks, how much will your bill be if you are on the phone for 4 hours and 22 minutes? What that's asking this is asking, what is y if X is equal to 4 hours and 22 minutes. Now, the problem here is it's not 4.22, that's hours. And even then, 4.22 is not, like 22 minutes is not 0.22 hours. So we need to convert this to minutes because our X value is measured in minutes. If it was measured in hours, then we would have to convert it to hours. But right now, this will equal 4 times 60 minutes an hour plus 22. That's 244 minutes. Wait, no, 62 minutes. I can do math, I swear. Yeah, 240 plus 22 is 262. Good. So that's what it's asking. What is y if x is equal to 262 minutes? So we replace x with 262 and we will be done. Y equals 0.11 times 262 plus 34, which is equal to $62.82. Any questions on that? All right. We're assuming that we're in this nice, super like there's no air in this room. So the candle, there's a candle that's burning, and the height of the candle is a linear function of the amount of time it has been burning. So, and we're doing it in centimeters. We're not using freedom units here. After 2 hours of burning, the candle has a height of 23.6 centimeters. And after 5 hours of burning, the candle has a height of 12.9 centimeters. What is the initial height of the candle? Okay. We're not given a rate, but we can create a rate since we know it's linear. So let's define some variables. Let t equal time. And h equal height. Or you could make y equal to height, or whatever variable you want, but h seems to make sense. So, what should I do?
Subtract 12.9.3.6
Mm-hmm.
and then divide by 5.
Yep. Divide by 3, because it'd be 5 minus 2. So,
Often 5.
yes, Matthew's absolutely correct. We have, if we're looking at it as a function of time, so here's time, and here's height. The candle is going down in size. Its height is decreasing as time increases. So as time gets further and further right, the height goes further and further down until it eventually fizzles out and stops for whatever reason. If you don't like, there's something about having to properly prep a candle. You have to like let it go for like 5 hours, otherwise it won't burn right, and it'll get that ring of death on the sides, But either way, so we're given 2 initial conditions. We're given from so let's highlight this. The blue, after 2 hours of burning, the candle has a height of 23.6 centimeters. This means we have from the blue, we have the point 2, 23.6. And from the red, after 5 hours, 12.9 centimeters, from the red, we have the point 5, 12.9. And so as Matthew suggested, we're going to find the rate. We're going to find the slope by using the slope formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Technically speaking, it should be h sub 2 minus h sub 1 over t sub 2 minus t sub 1 because our variables are t and h, but whatever. You get the idea. So it should be 23.6 minus 12.9 divided by 5 minus 2. Now, you didn't need to use math to figure this out. You could find, just like how we find average speed on a on a road trip, right? You know how many miles you've traveled, you know how long it took you, like total number of miles traveled divided by total number of hours gives you your average speed. The same thing could be done here. You know that there's a difference of what's 23.6 23.6 minus 12.9. I don't know off the top of my head. It would be 10.1. No, 10.7, 10.7. You know that it decreases by 10.7 over 3 hours, and that would be your rate. So you could do it without using math. But either way, it goes to be about I did something wrong. Because what I'm going to get right now is 3.57. Why do I know that I'm wrong? Does anybody see why I know that I'm wrong? 3.57, positive 3.57. A positive sloped line would be increasing. It would be going like that. And that makes no sense. So I must have made a mistake somewhere. What did I do wrong? There's
But you're supposed to subtract 23.6 from 12.9.
That is correct. So either like it doesn't matter which way I do it, but I flip-flopped one of these ones. Either this needs to be flipped or this one needs to be flipped. One of them needs because I did so technically speaking, if I let's label these, and this is why I do this every time for myself. X sub 1, y sub 1, and x sub 2, y sub 2. Yes, I should have 2 minus 5 instead. Well, I mean, in this case, it doesn't matter. Regardless of how I do it, that's gonna bug me though. I'm gonna make this x sub 2. Otherwise, it doesn't match up. I can't handle that. So regardless, it'll give the same number, negative 3.57, but it'll be negative now. And that lands up with what we would expect. The rate should be negative because this should be a decreasing function. Okay. With this problem, okay, average rate of change, and that's it. Cool, 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 cool. All right. Now that we've gotten the slope, it says, what is the initial height of the candle? So we need to know what the height was. So let's underline that, or highlight that rather. We want h when t is equal to 0. That's how we write that in mathematics. If we want to know the initial height is when no time has passed, when the time is equal to 0. So we want h, the height, when t is equal to 0. Well, in order to find out that, we need to find the equation, because right now we just have the slope. So we can use the point 5, 12.9, and doing so gives us y minus y sub 1, so y minus 12.9 equals m, which is negative 3.57 times x minus 5, which, wait, where's my calculator? No, I left my calculator at my office. I have my other one. Should always have 2 calculators on you. Do we all have 2 calculators on us for all, just in case we lose our first one? don't actually hold two calculators unless you're a math teacher. There are so many calculators in my house. My wife has three. I have two. And then we also have three scientific, two scientific, and then four graphing calculators. So we're prepared in the apocalypse for everything. Anyways, this will become, okay, so y equals negative 3.57x plus 17.85 plus 12.9. Wait. What's going on here? 17.85 plus 12.9 is 30.75. Okay. So this is going to be y equals negative 3.57x plus 30.75. So we want to know when, not, it should not be y. I should have just made, like, let's change these to y and x. Otherwise, it should be an h and t, and I didn't do that. I got carried away with the x's and the y's. So y of 0 is equal to negative 3.57 times 0 plus 30.75, which is just 30.75 centimeters. Here's the thing, by the way. I would argue, and this is just something I want you to know, you have defined your variables. And from the context of the problem, height is measured in centimeters. From the context of the problem, height is measured in centimeters. Since you've defined your variables, you can box in 30.75 and just write it like that. You don't need units in my class or in any class. So if you decide to take another math class from someone else and you define your variables and you box it in and they mark you down for not labeling this with the number of variables, you should absolutely go talk to them and say, I deserve a point back. Y is already clearly known to be in centimeters, so I should get points back. I will defend you to the death on that one too. We've already lost one of our mathematicians because of that in this college. And Aaron Harris, my office mate, he has a scar on his eye because of our battle. He gave up. True story. No, not actually true. But anyways, but you can add the centimeters, it's fine. Another thing, just one more note, is that technically speaking, you didn't even need to plug in 0. That's the y-intercept. So you automatically know that it's 30.75. That's another way to do it, but either way. Okay. Next. Last thing for today is the average rate of change. Let f be a function defined on an interval a to b. Then the average rate of change which we're going to abbreviate AROC so we don't have to write average rate of change ever again. The average rate of change of f on a comma b is given by the formula m sub avg is equal to f of b minus f of a over b minus a. That is the formula for the average rate of change. Okay, a couple things though. Why do I have to learn a new formula? That's so lame. Hate that. It's not a new formula. This is just the slope formula with function notation. I'll elaborate. But this is just the slope formula with functional notation instead of y's and x's. F of B is a y value. F of A is a y value. B and A are x values. That's all this is. So the visualization is over here. This is A right here. This is B. And then remember, the y value of your point is the function evaluated at that x value. So this is f of A. And this is f of B. The slope, so then this means that this is the point right here. This is the point B comma f of B. And this is the point A comma f of A. So x sub 2, y sub 2, x sub 1, y sub 1. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It's literally the slope formula. It's just written in a different way. Why? Because functions, once again, they have good interpretations, that they help us see things a little bit better sometimes. So we're going to look at it purely in a mathematical context. But what I will tell you is that you can use this formula to figure out things. I mean, they're very, very contrived examples, but like maybe if you want to know the concentration, the average concentration that dissipation of a drug in a bloodstream, like ibuprofen, there's probably a function that you can figure out, and you can figure out what the average rate of change of the percentage of like the milligrams of ibuprofen in the blood over a certain amount of time. Or you can use this to figure out your average speed on a road trip and things like that. The more important thing for this is a lead-in to a thing in mathematics called derivatives. This is what we call the secant line, is that dashed line, and that has a close relation to a thing called the tangent line, which is something you study in Unit 2 of calculus. Unit 1 is on limits, Unit 2 is on differentiation, on derivatives. And so this is kind of the lead into that concept. So find the average rate of change of the following functions on these intervals. So f of x is equal to x cubed minus x plus 2 on the interval 1 to 3. So this, the interval from 1 to 3, that means that a is equal to 1 and b is equal to 3. So m sub avg is equal to f of 3 minus f of 1 divided by 3 minus 1. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Where x sub 2 is your larger number. Though it doesn't really matter, you can flip-flop them, it's fine. So we can compute f of 3 and f of 1 off on the side, or we can compute it as we go along. I'm going to compute it on the side because I don't trust myself to do this math with all the parentheses and stuff carefully. That's going to be 3 cubed minus 3 plus 2. That'll be 27 minus 1 is 26. And f of 1 would be 1 cubed minus 1 plus 2. That's going to be 2. So we have f of 3. Sorry, let me stop talking so fast. We have f of 3. We have f of 1. We have everything we need. This is equal to 26 minus 2 over 2, which reduces down to 12. These are purely in a mathematical context, but this can be general, like this can be actually used in real life applications, though they are very, very contrived, as I said. Because life isn't super perfect like this. Life doesn't usually work out to be nice, neat functions. But later on, like once you get more and more math under your belt, you can use average rate of change in a different way to actually compute things. So this one, y is equal to the square root of x plus 2 from a equals 7 to b equals 10. Same question, worded different. It told you the a and the b values, but you don't have a function. Yes, you do. Remember that y is synonymous with f of x. They mean the exact same thing. So this is really
f of x equals square root of x plus 2. So m sub avg would be f of 10 minus f of 7 divided by 10 minus 7.
Now here, it's not going to be too terrible to plug these values into the calculator, so that's what I'm going to do.
That'll be equal to the square root of 10 plus 2 minus the square root of 7 plus 2, all divided by 3, which is the square root of 12 minus 3 over 3, which is approximately 0.1547. Depending on whether or not the computer wants you to write it as an approximation or in exact form. Any questions on that? We are very close. Just one more problem. My favorite one of the average rate of change problems, just because it's interesting. Conceptual problems. I always like conceptual problems. Problems that we have to think outside the box. So the graph of G is given. Find the average rate of change from x equals -4 to x equals 2. But I'm not given the equation. You don't need it. You don't need it. The average rate of change, this is our A value, and this is our B value. M sub AVG, we're dealing with G instead of F. So instead of F of B minus F of A, it's going to be G of B minus G of A. So it's going to be G of 2 minus G of -4 over 2 minus -4. So you might be like, so this is what I do as a mathematician. I need to find the average rate of change. I've never done this problem before, but I do know the average rate of change formula, which I will, by the way, I will be providing it on the exam. If there is a problem with the average rate of change on it, the formula will be provided. So you don't have to have it memorized, even though you don't really even need to memorize it. It's just the slope formula, but I digress. So just by definition, the average rate of change is G of B minus G of A over B minus A. So we at least write that down. Now that we've written something down, we can figure more about it. G of 2, that's the function value, that's the y value associated to x equals 2. So G of 2 is equal to 7. And G of -4 equals negative, I just covered it up, I can't read. G of -4 is equal to -5. So we didn't need the equation of the equation of the function to figure it out. We already had the graph, we had enough information. So it's going to be equal to 7 minus -5 over 6, which ends up being 2. And as an added bonus, if you draw the line connecting these two, you don't need to draw this, but I'm just going to show it for the sake of an argument. You'll notice this line has a slope of 2, up 2 over 1. Haha. The slope of what we call the secant line is 2. All right, that'll do it for today. If you have any questions, please feel free to email me. Otherwise, you guys have a great rest of your day, a great weekend, and stay off social media as much as you can. It's not good for you. You know the deal. Set it for about 6 weeks now, but you know the deal. Stay off social media. It's not good for you. Avoid the doom scrolling. It's even worse for you. Have a great weekend.